At the surface, the Cretaceous seas might have looked familiar, but just below, they were something else entirely. Vast inland seas stretched across continents, while deeper waters faded quickly into darkness, hiding animals so extreme that even today, they feel almost unreal. Some of them may have reached the size of modern whales, suggested only by partial fossil remains, with their full forms still unknown. One of the most enigmatic was Nanimoteuthis. Some have wondered, could the legend of the Kraken have a distant echo in reality? This giant cephalopod, related to modern deep-sea cirrus octopuses, is known primarily from fossilized beaks. And yet, from these fragments, scientists have attempted something bold, reconstructing its size. By comparing the dimensions of these jaws with those of living and extinct cephalopods, estimates have ranged from about 7 to an astonishing 19 meters in total length, placing it among the largest known cephalopods, perhaps even large enough to interact with marine reptiles like mosasaurs. But here, uncertainty casts a long shadow. These estimates rely on assumptions about body proportions that remain unknown. Was Nanimoteuthis elongated like a squid, or more compact like an octopus? Its beak morphology hints at a durophagous diet, feeding on hard-shelled prey, such as ammonites, or other shelled cephalopods, rather than active predation on large vertebrates. So while the image of a tentacled giant grappling with marine reptiles is compelling, the evidence invites caution. The mystery remains: how large was it really? If Nanimoteuthis represents uncertainty, Parapozosia offers something more concrete. This genus of desmoceratid ammonites included species that could exceed 2 meters in shell diameter, making them the largest known ammonites and among the heaviest cephalopods ever to exist. Around 80 million years ago, they drifted through seas that covered parts of Africa, Europe, and North America. Their massive coiled shells moved through the water column, though how actively they swam remains uncertain. Their size alone suggests a life far removed from the scale of most modern cephalopods. Predators, of course, were never far away. Among them, Predatory stands out as one of the most specialized mosasaurs. Its body was remarkably streamlined, more so than any of its relatives, with a narrow, pointed head and a highly fusiform shape. In silhouette, it begins to resemble something unexpected: an ichthyosaur. Ichthyosaurs had vanished millions of years earlier, yet mosasaurs like Predatory approach similar forms under similar pressures, with bodies suited for efficient, sustained swimming in open water. A different kind of mosasaur specialization appears in Megapterygius, a late Cretaceous mosasaur from what is now Japan. Its name means large wing, referring to its unusually long, wing-shaped flippers. Both pairs of flippers were highly developed, and the hind flippers appear to have been even larger than the front ones, an unusual condition among mosasaurs. Even more striking is the evidence from its dorsal vertebrae. Some neural spines change orientation in a way interpreted as possible support for a dorsal fin. If correct, Megapterygius may represent one of the clearest cases of a mosasaur with a shark-like stabilizing fin along its back. Together with its long flippers and likely tail fin, this suggests an animal adapted not only for speed, but for control, turning, braking, and maneuvering through the late Cretaceous seas with unusual precision. Elsewhere in these seas, another kind of extremity took shape. Albertonectes, an elasmosaurid plesiosaur, possessed the longest neck known among marine vertebrates. over 7 meters, composed of an astonishing 76 cervical vertebrae. What role could such a structure serve? It likely allowed the animal to approach prey with minimal disturbance, while its body remained at a distance. In Albertonectes, this anatomy reaches an almost surreal scale, pushing the limits of what a vertebrate body can sustain. Not all unusual forms were about size. Some were about precision. Xenodens, a small mosasaur, possessed one of the strangest dentitions ever discovered. Its teeth were short, flattened, and blade-like, forming a continuous cutting edge, almost like a serrated knife. No other known tetrapod shows this exact arrangement, yet similar designs appear in distantly related animals, such as dogfish sharks and piranhas. Such a dentition suggests a feeding strategy adapted to slicing through soft-bodied prey or dense schools of fish, though its exact ecological role remains uncertain. Even fish developed bizarre shapes. Cephalopods, a giant predatory fish of the western interior seaway, reached lengths of up to 6 meters. Its enormous jaws, lined with numerous sharp teeth, could open wide like a trapdoor. When closed, its blunt snout gave it an almost bulldog-like appearance. Fossils have revealed dramatic evidence of its feeding behavior, sometimes preserving large prey swallowed whole, occasionally too large, leading to the predator's own demise. Another giant took a very different form. Archelon, the largest turtle ever documented, lived during the late Cretaceous and could reach more than 4 meters in length. Unlike many turtles, its carapace was not a rigid dome of heavy bony plates, but a lighter structure, likely covered by thick skin, recalling the conditions seen in modern leatherback turtles. With a body mass of several tons, it was closer in scale to a rhinoceros than to any ordinary turtle. Its powerful beak suggests a diet that may have included hard-shelled mollusks, crustaceans, and softer prey such as squid or jellyfish. Cretaceous cephalopods also included highly unusual forms. Nanimoteuthis, a relative of modern squids, reached lengths of around 3 meters and lived in open waters. It possessed a distinctive internal shell, or gladius, shaped like a paddle with a broad, flattened posterior end. The function of this unusual structure remains unclear, possibly related to swimming efficiency, stabilization during rapid movement, or another role not yet fully understood. Primitivus manduriensis swam in the warm waters that once covered what is now southern Italy, particularly the region of Puglia. This elongated aquatic squamate, possibly related to early snakes, had a body plan that seems strikingly unfamiliar. Long, sinuous, and adapted to marine life. Its very name, inspired by a local wine, connects deep time to present culture. Its form suggests flexibility, both literal and ecological. Another fish reveals a different kind of survival. Stratodus, a large, elongated predator reaching about 5 meters in length, belonged to a group whose modern relatives include reef and deep-sea species. Yet it lived in shallow inland seas, hunting perhaps, in a manner reminiscent of modern billfish, darting through the water with speed and precision. Remarkably, it survived the mass extinction at the end of the Cretaceous, enduring when many giants did not. Not all of these strange forms belonged to the open sea. In the river systems and coastal waters of North Africa, Onchopristis moved through environments shared with some of the most famous predators of the Cretaceous. It was a large saurscate, reaching several meters in length, with an elongated rostrum lined by long barbed denticles. Superficially, it resembled a modern sawfish, but this was convergence rather than close kinship. Onchopristis was closer to rays, a cartilaginous fish shaped by similar ecological pressures into a similar weaponized profile. Fossils from the same ecosystems suggest that Onchopristis was also prey for Spinosaurus, linking this strange saw-snouted fish to one of the most unusual predatory dinosaurs ever known. In shallow waters where rivers met the sea, that saw-like snout may have been used to detect, disturb, or strike prey moving through the sediment and murky water. From these river margins, the story returns to the open sea, where Cretaceous sharks had taken on forms just as unusual. Aquilolamna, from the late Cretaceous waters of what is now Mexico, was an elasmobranch with a body plan unlike that of most sharks. Its pectoral fins were extremely long and wing-like, giving it a silhouette closer to a manta ray than to a typical predator. It appears to have occupied a filter-feeding niche, moving efficiently through open water with a long tail and exaggerated fins adapted for sustained, low-energy swimming. Other sharks took the opposite path. Tychidus was a large lamniform shark adapted for a diet that was highly unusual for its group. Instead of blade-like cutting teeth, it carried broad, flattened crushing teeth arranged into pavement-like dental plates. In some reconstructions, the jaws contained hundreds of these teeth, forming a powerful apparatus for breaking hard-shelled prey, such as ammonites, marine turtles, or other armored animals. Subadult specimens already reached several meters in length, and some species may have approached nearly 10 meters, making Tychidus one of the largest sharks of the Cretaceous. And then there was Cretoxyrhina. Often called the Ginsu shark, it was built around speed, cutting power, and open water predation. Its streamlined body and sharp slicing teeth made it one of the apex predators of the Western Interior Seaway around 85 million years ago. Fossil evidence shows that it fed on large marine animals, including fish, pterosaurs, plesiosaurs, and even mosasaurs. In a sea already filled with reptiles, giant fish, and armored prey, Cretoxyrhina was not simply another shark. It was one of the most efficient hunters of the entire Cretaceous ocean. The Cretaceous seas were not ruled by a single kind of giant. They were shaped by many different lineages, reaching extremes in different directions. Shells wider than people, necks longer than boats, sharks built for crushing armor, and predators streamlined for speed in open water. Some of these animals are known from skeletons, others survive only as fragments, enough to reveal that they existed, but not always enough to show us exactly what they were. And that may be the most unsettling part of these ancient seas. What we know is already extraordinary. What remains missing may have been even stranger.